Hi, welcome. This screencast covers organic molecules that are important to the human body: carbohydrates, lipids, proteins, and nucleic acids. We'll start with the carbohydrates. This group of molecules is important to the human body primarily because they provide the energy to power everything our bodies do. The contraction of our muscles, the conduction of electricity in our nervous systems, and the movement of food through our digestive system all are powered by energy coming from carbohydrates. In addition, carbs have a smaller role in supplying some of the necessary materials that cells need to build structures, and we'll look at that a bit more later in the class. Carbohydrates, if eaten in excess of the body's needs, can be converted to fat and stored in adipocytes or fat cells. This is a long-term way of storing energy for the body. If, at a future point, the body is depleted of energy coming from carbohydrates, perhaps because you are fasting or exercising, it can take the fat stored in fat cells and use energy from breaking down the fat to power the body. This is the basis, by the way, of the Atkins diet. Basically, if you do not eat enough carbs for the body's energy needs, your body will start to break down fat and take energy from it. For that reason, you can lose a lot of weight very rapidly on the Atkins diet. However, it is terribly unhealthy because that diet does not supply balanced nutrition. All of the vitamins, minerals, and other nutrients you would receive packaged up with foods that are primarily carbohydrates. In addition, while most of the body's organs and tissues can switch over to deriving energy from fat breakdown, the brain cannot, and so the brain is then unable to function properly. This slide looks a little at the structure of carbohydrates. Basically, carbs are molecules that contain carbon, hydrogen, and oxygen, and they have a very specific ratio of these atoms. Twice as much hydrogen as oxygen. On the right side of the slide, I have structural representations of three common carbohydrates in the human diet: glucose, galactose, and fructose. As you look at their molecular formulas, you'll notice that in all cases there is twice as much hydrogen as oxygen in these molecules. If you look even closer, you'll notice that actually they all have the exact same molecular formula, C6H12O6. This is because they are isomers, molecules with the same types and same numbers of atoms. They just vary in the way that those atoms are arranged. Because they are all isomers, galactose and fructose actually are converted to glucose in the body because glucose is the carbohydrate that cells break down for energy. So all carbs that we ingest in the end get processed into glucose within our bodies. One last thing that I want to mention about carbohydrates structurally is that they can be classified by size into three different categories: monosaccharides, disaccharides, and polysaccharides. Glucose, galactose, and fructose, the carbohydrate molecules you can see on this slide, are all examples of monosaccharides or simple sugars. They are different types of sugar in its smallest form. If we go to the next slide, you'll be able to see how disaccharides and polysaccharides differ from the monosaccharides. Here we have simplified representations of a monosaccharide, a disaccharide, and a polysaccharide. A monosaccharide is a single carbohydrate molecule. It is relatively small in size, and so when we eat simple sugars or monosaccharides, they get absorbed across the wall of the intestines and into the blood very quickly. This is why a diabetic who is suffering from low blood sugar or someone else who is hypoglycemic would be given fruit juice or candy to bring blood sugar levels back up. Those foods contain high amounts of simple sugars, and because simple sugars are absorbed very rapidly, they cause blood sugar to rise almost immediately when ingested. This is good for someone who is suffering from a low blood sugar situation, but not necessarily great for the rest of us. It's not particularly healthy to have sudden spikes in blood sugar for reasons that we'll discuss later in the course. If you look at the representation of a disaccharide, you'll notice that a disaccharide is just two monosaccharides hooked together by a chemical bond. There are several common disaccharides in the human diet, including lactose, which is found in dairy and consists of a glucose molecule bound to a galactose molecule, sucrose, which is table sugar, the sugar we bake with and use in desserts, and is composed of a fructose molecule bound to a glucose molecule, and maltose, which is green sugar, the sugar found in alcohol, which consists of two glucose molecules hooked together. Because disaccharides are twice as large as monosaccharides, they have to be broken in half. Basically, the two monosaccharides break apart from each other before they can be absorbed in the gut and enter the bloodstream. The last type of carbohydrate represented here is a polysaccharide. If you look at it closely, you'll notice a polysaccharide is just a whole bunch of monosaccharides bound together. Starch is an example of a polysaccharide that's common in the diet. Potatoes, carrots, and corn are examples of vegetables that contain a relatively high amount of starch. What happens when we eat those foods is the body breaks apart the starch, or the long chain of simple sugars, into individual monosaccharides. This happens with enzymes in the gut. Once the polysaccharides are broken up into monosaccharides, the sugar is absorbed into the blood and increases blood sugar. However, foods such as potatoes, carrots, and corn, even though they contain a lot of sugar, are considered to be complex carbohydrates. This is because the sugar is in the more complicated polysaccharide form. Complex carbohydrates do not cause the same spikes in blood sugar as do simple sugars because they are not absorbed immediately. Rather, they are broken down much more slowly over time, and so you see a slower rate at which carbohydrate is then absorbed into the bloodstream. You may not have realized that potatoes, carrots, and corn contain a lot of sugar because they don't necessarily taste really sweet like apple juice or a candy bar. The reason for this is because sugars in the polysaccharide form do not taste sweet like sugars in the monosaccharide or disaccharide form. However, polysaccharides are still sugar, and diabetics and those with blood sugar issues need to monitor the amount of starchy vegetables that they eat. Vegetables like broccoli, peppers, onions, and Brussels sprouts are a better bet because they do not contain a lot of sugar in the form of starch. This concludes the screencast on carbohydrates.